Alright guys, this is the video for the F.12 remediation. So if you need to retake this, you should be watching this video. Make sure you look at that test. And again, you're looking at F.12 on the sequences test. It says construct linear and exponential functions, including arithmetic and geometric sequences, given either a graph, a description, input and output values. That could also be from a table. So let's take a look at what we've got. Here's a graph of two sequences. So you can see the blue dots are sequence A, the black dots are sequence B. Make sure as I go through this video, you take notes, and then you'll, at the end, correct your example on your test. So for sequence A and B, let's go ahead and fill in the table. We're just going to look at those numbers from the actual graph. So we can see that the first term is 2, the second term is 5. I'm on sequence A right now, and then we have 8, 11, 14, and then 17. So that'll be sequence A. Sequence B, we start, it looks like the first term right here is 1, and then the second term is 2. I'm looking at the Y values there. Third term is 4, and then 8. And then this last one right here is 16. So if you see the pattern, you can see the sixth term for sequence B is actually not on the graph. It will be 32 because every value is being doubled to get to the next term. Okay, so then it says describe a way to produce a new term from the previous term. So for sequence A, what are you doing with 2 to get 5? And then 8, and then 11. So are we adding the same thing every time? Are we multiplying to get to the next term every time? Hopefully you're thinking we are adding 3 to the previous term to get to the next term. Okay, so then is sequence A arithmetic, geometric, or neither? Remember, when you're adding a constant, that means it's arithmetic. You can also look at the graph. You can see that the blue dots create this linear trend. So that would be an arithmetic sequence. We're going to write a recursive equation to define sequence A. So remember, recursive just means you need the previous term in the equation, or you need the previous term notation with the adding 3. So again, that recursive formula in general, I'll write this over to the side in red. So A of A of 0 or A of 1. You have to use one or the other. So if we use A of 0, you'll fill in for the 0 term. If you use A of 1, this is an OR here, you'll fill in for that term. And then you also list the nth term is the previous term. And then remember, it's either multiply, add, or sometimes we subtract. So again, that is dependent on what you're actually doing. So on this one, we're adding 3. So right there, we'll have a plus 3. And then you have to list the domain. So for n's, for 0, it'll be 1 higher, so 1. And then for, if we use the first term, this will stay the same. So you'll have the previous term. Remember, this right here just means previous term, guys. A of n minus 1. And then you'll either multiply, add, or subtract again there. So fill in for that. But the domain this time, since we started with 1 here, the domain will go up by 1. So now the domain would be n is greater than or equal to 2. Okay, so let's try this one. Excuse me. So I'm going to start with the first term since that's what we have in the table. So in the table, the first term is 2. So I'm going to say that the first term is 2. That's all that says. The first term is 2. And then to get to the next term, I'll take the previous term, so a of n minus 1, and then we're adding 3. Okay, remember what you stated in the description. You're adding 3 to the previous term. So then add 3 to that, and then list the domain. So for n's that are greater than or equal to, and since we started with the first term, it'll be 1 higher, so starting at 2. And that's it for recursive for that arithmetic sequence. Now let's look at sequence B. Describe a way to produce a new term from the previous term. So what are you doing with 1 to get to 2, 2 to get to 4, etc.? You're doubling or you're multiplying by 2. To the previous term to get to the next term. Remember, that's always how we describe. If we can describe it, what are we doing every time to the previous term? Okay, so since we're multiplying by a constant, that means it's geometric. You can also look at the graph. It is an exponential trend here. So that means it's geometric. And then the last thing, we're going to write a recursive equation. Again, recursive means using the previous term to define sequence B. So it's going to be the same thing I wrote up here in red. So I'm going to reference this again. So I'm going to start with the first term. The first term of this one is 1. And then to get to the next term, I take the previous term. So a of n minus 1. And this time we're multiplying by 2. So I'm going to say we're multiplying by 2 instead of adding. And then don't forget your domain. So for n's that are greater than or equal to, I started with 1 here. So I'll go up by 1. The domain will start at 2. And again, that just means that you can use this formula, so taking the previous term, so 1, and multiplying by 2, and then taking 2 and multiplying by 2 to get 4, and etc. So that's recursive equation. This last one is also going to be recursive and then also nth term. So the explicit formulas, this one is a select all. So there will be multiple correct answers. So I'll show you how to navigate that when we get there. So it says, here's a visual pattern of dots. The number of dots, d of n, is a function of the figure n. What values of n make sense in this situation? What values of n don't make sense? All that's asking you guys is for the figure number, so figure 1, 2, and 3, what makes sense and what does not make sense? So let's start with what makes sense. It makes sense to have positive integers. We started at 1, so 1 is a positive integer, and then 2, and then 3. You could draw figure 4, 5, and so on. It does not make sense to have decimals or negatives. You can't have a figure 1.5 or a figure -1 or -2. That just doesn't make sense. We've also talked about what makes sense for the domain when we're cutting paper. Like you can't cut a piece of paper a negative amount of times. So that's another example for when n makes sense and doesn't make sense. Okay, we want to complete the table. So we've got, let me change my color here. We've got 1 dot, we've got 3 dots, and then we have 5 dots. So the first figure, we have 1 dot. Second figure, we have 3, and then 5, and then hopefully you can see the trend. You're basically just adding like 2 on both ends, like to the top and to the right. So then you're just adding 2 dots every time. So then 7 and 9. Okay, so then it says select, I'm on part C now. Select all the expressions that represent the number of dots. So basically what you're doing here is stating which of these 6 formulas work to get the sequence 1, 3, 5, 7, 9, and so on. So I would pick out the recursive ones and just make sense of those. So the recursive ones are the ones where it lists a term and then uses the previous term. So you're looking at 3 and 4 here for recursive. So let's look at that. This one says the first term, I'm looking at Roman numeral 3 here. The first term is 1. So is the first term 1? It is. And then it says we're going to add 2 to the previous term. Are we adding 2 to the previous term here? And then, so yes, and then check your domain. So we started with 1, it went up by 1, so this one is correct. Okay, let me clean that up a little bit. All right, part 4 says the first term is 1, which is correct, but then it says you're adding 1 to the previous term every time. Remember, f of n minus 1 is just previous term. We're not adding 1 every time to the previous term. We're adding 2. 1 plus 2 is 3. 3 plus 2 is 5. So that one's not going to be circled because that one does not work. Okay, the other 4 are explicit or the nth term formulas. So what I would do is just plug in the values and see which ones work. So I'm gonna show my work down here. So for I, I'm going to plug in 1. And I should get, if I look at the table, when I plug in 1, I should get 1. So f of 1 equals 1 plus 2 times, and again, n is 1 here. I'm plugging in 1. You can either type that in your calculator or do that in your head. 1 minus 1 on the inside is 0. 0 times 2 is 0, and 1 plus 0 is 1. So that one does work. If it works, then you need to try a second one. So let's plug in 2. Again, if I look at the table, I should get 3 when I plug in 2. So I'm using the same formula from Roman number 1. 1 plus 2. This time n is 2. So 2 minus 1. Let's see if that works. 2 minus 1 is 1. 1 times 2 is 2. And 2 plus 1 is 3. So it looks like this one also works. So far we have 2 of the 6 that are correct. Let's jump down to Roman numeral 2. Let's see if that one works. So again, I'm just going to plug in 1 and 2 for my n, and I should get 1 when I plug in 1. I should get 3 when I plug in 2. So f of 1 equals, on Roman numeral 2, so I'm following that formula where I see an n, I'm replacing it with 1 this time. 1 minus 1 is 0, 0 times 1 is 0, 0 plus 2 is 2. If you look in your table, the first term, or f of 1, is not 1. You only have 1 dot, and we got 2, so this one cannot be true. Really, I should be using D of n here, not F, but that's okay. All right, now I'm on Roman numeral 5. So I'm going to plug in 1. 2 plus 1 times 1 is 2. 1 times 1 is 1. 1 plus 2 is 3. So is f of 1 3? It is not. So 5 will not be selected, and then we just have one more to check. All right, so D of 1, again, this should be a D, but I'm just testing the point, so that's okay. So D of 1, I'm on the last one, is 2 times 1 minus 1. 2 minus 1 is 1. If I check it in my table, the first term is 1, so that one works. And then I'm going to try it again. So D of 2, I'm going to plug in 2, so 2 times 2 is 4. 4 minus 1 is 3. So that one also works. So you have 3 selections that are actually true for this part C. So if on your test you missed you only circled 1, you did not get full credit. If you circled 2, again, you did not get full credit. So just make sure you, when it says select all the expressions that represent the sequence, make sure you select all that apply. Okay, now that you've finished this video, you should go to your test, and there are 3 problems on the test that correspond to this F.12 sequence remediation. So go ahead and correct that, and then see your teacher for your retake.